let's see. Waiting for the next song to come on. Kind of quiet. Um, what are we doing? What's going on? How is everybody? I don't know why this apartment is so warm. Uh, it's only like 75 or something outside, and I got the windows open, but I don't know. I need to figure something out because over here in this corner, it's just like, I guess it's because all the electronics or something are over here. But it's pretty warm over here. I don't know what to do about it. I have to kind of leave the desk on like this wall that runs this way because the internet cable, I mean, I couldn't use it, the Wi-Fi, but the internet cable comes in on this wall here. So I'm in the corner of the room and there's a wall that runs this way with the windows on it, and then the wall that I'm facing. So I have to be somewhere in that vicinity. Or, you know, I'm the only one that lives in this apartment. I could just put the desk in the middle of the room if I wanted to. In my old apartment, when I was living in Oregon, I put the um, bed in the middle of the living room. And that was because my upstairs neighbor was so loud at night that I couldn't sleep in my bedroom, so I had to move the bed into the living room. And it was actually kind of nice because you have all this open space all around you. I don't think a lot of people would like that, but I don't know, it just felt like you were like in the middle of an ocean or something like that. So maybe I'll do something like that with the desk situation and the heat situation. But I don't know. Yeah. Um, so I don't have much planned today. It will be mostly cleaning things up. There'll be some interesting things that we'll cover. Um, I guess we'll just get started. Don't have much to say, and not much has happened since now and last night. Uh, I cooked breakfast today. I made some eggs, and I need to get a new pot or pan because you can kind of see it there in the background where the range is at, right here. It's right here. It's like a stainless steel pan, which is nice, but it gets so like everything sticks to it. And I try to do like, you know, put butter in the pan or maybe even oil or something, but it's just got like, I don't know, you let something sit in the pan for too long and it just sticks to the bottom of it, and it's so it's not difficult to clean, but it's really annoying to clean. So maybe I'll get a cast iron pan or something. But then you gotta, well, I don't know if you have to keep those like um seasoned or something, or if you season it once and you're good. But I know there's special rules about cleaning it. Like you don't want to clean it in the sink because it can like rust and stuff. But you can just use like steel wool on it and it's really nice to clean. So I might look into that too. If I plan on using the pan more often. So that was about it, and then this morning I just did some chores, and we're here now. So let me jump over to the code. So it's kind of the example that we've been working on is working, um, but I think it can be improved in a lot of ways, and that's what we'll be working on today. Um, But to kind of give you an idea of what's happening here, the whole spiel is that um, this is a image here, and as that mesh, it's really just plain geometry that's been placed in the scene, and then the texture of that geometry or that material is being created from this render target. And before all that happens, before we go into our main like animation loop, we create this separate scene that gets different shots, like camera shots of the mesh. So here's our mesh here, whatever it is. It's a three-dimensional object. And then we get different shots of the object. We put all those shots into a texture, and then we're using that texture like a sprite sheet or like a sprite atlas or something. So depending on the rotation of the camera relative to this object here, we're changing the texture's properties so that we get the sprite that matches up with the like current rotation and stuff relative to where the camera's at. So the camera is moving when I release it like this. Well, when it's got the orbit controls, so the camera is moving, but every time that the controls is updated here, it's calculating the next like it's offsetting that texture here. So that's what's going on, and this is done at runtime, but what I'd like to do is extract that image from the texture. And then what we can do, if we have that image, we can just use a normal like texture loader to load that image. We don't have to do all that at runtime, like creating the scene and you know, getting all those camera shots and stuff and making the sprite atlas. Once that's done once, then we can just load in that texture, because we'll have it like saved to disk, and then we can just load in that texture like you normally would with images. So that's the first thing I want to do. And then the next thing is you know, taking out all this stuff related to doing that will go away. Like this render target business, that will go away once that's completed. And we'll load the texture differently, but we don't have to make like a separate scene and do all that. And I'll show you, it's going to be a lot simpler. It'll be like we have the atlas ready to go, but we need to create it one time. And that's it. Once we have that, then I want to update this part of it. I'm not happy with this. I think it's a little confusing. Maybe not confusing, but I think it could be better. So what I want to do instead is to use a sprite node material, and I'll show you how to update the color node of this node material. And this math will be a little bit simpler when we go to figure out what the offset needs to be. I think that will give us quite a lot of content. So that's the plan for today. So there's kind of like three parts to this. There's going to be getting that image as like a separate file that we can load, and then the second part, which is really, I'm going to split it into two parts, so we got three total. The second part will be changing out this material here to a sprite node material, and then like how do you deal with the texture UVs? How do you do what three.js is doing with this offset and this repeat? How do you do that with TSL? So TSL is like three.js's like built-in shading language, which can compile into GLSL, I guess, or like WebGL and Wigzl. So it'll involve just a little bit of this, not too much. It'll be pretty easy. And then part 3 is going to be, now that we have that done, how do we change this to accommodate for that? So I guess we'll just get started. So the way that I'm going to do this is I'm going to make a separate like helper function that will render to an off-screen canvas this scene here. Where's our scene? This scene here. And then once it's rendered to the off-screen canvas, it only needs to render to it once because we're using array camera. Then what we'll do is we'll create a URL object out of that. We'll create a blob out of the canvas. It has methods for doing that. We'll create a URL out of that blob, and then we're just going to stick it into the web page. Once it's in the web page, then we can just right-click it and download it, and we're good to go. We can save it and all that. And then we have it, in the file system, and then we can get rid of all this stuff, or a lot of it. I don't know if I want to get rid of it necessarily, but it'll at least be in the Git history. So let's do that. That'll be step 1. So I'm going to create a separate function for doing this, and we'll call it we'll call it sprite sheet. So in the end, I want this to return a blob, and I'll show you why. But here we'll make a function. We'll just export it to. So the way that I want you to be able to call this function is that you pass it in. So we know that we're going to need to render something, and all the renderers have this render method, which takes in an object here, and then the camera. So we know we're going to need a renderer, so let's make one. RevGPU renderer. Here, we know we're going to render to a canvas, so let's put that in. What? Oh. Well, we don't have the canvas, so let's make it. It's going to be an off-screen canvas, so that is something we can just call like this. I think we have to new it, though. But it requires you to pass in the width and the height. So what is that going to be? Well, we've got, some size. So this will be these images here for this here is going to be width by height, and I want it to be a square, so I want the size, the dimensions to be the same. So I'll just pass in the size here. But this is an array of, or it's like a row of images. Do I still have this? Yeah, if you look at this, it's going to be something like this, where it's just a row of images. 1 second. Oh, they want me to go to work. I don't want to go to work. Give me 1 moment. Let me reply to this message. I don't know what to say. How do I politely decline? Because I'm streaming and they want me to come in like right now. What time is it now? 2 o'clock? Okay, let me see what she says. Yeah, so where was I? Yeah, this is what we're gonna end up with. And this will be the actual canvas in a way. Well, it will be the canvas. So if we just had size by size here, we would just have one of these uh, sprites, but we need it to be, you know, more than that. We need it to be however many sprites we have in the texture or in the canvas. So it's going to be some amount of sprites. We'll just call it count. And then we don't have count yet. We don't have sprite either, but these will be options that we can pass in. So usually I put my options last, and we'll default. Hey, what's up? Default the size to 64. You finally made it to a stream. I am streaming a little bit later than I normally do. Yeah. So that's the size, and then we'll have the count, and we'll just say like 8 for now. So excited! Yeah. This is me. This is the stream. But we're working on this little example here, which is like this is a sprite material and a sprite in the scene, so it's just like a flat plane or whatever that has that texture being swapped out depending on you know, the like rotation of the camera and stuff. But I'm trying to get this to be something that we can load in at runtime as like an image. So we're trying to get this. This is kind of what we have in memory, but we need to get that and like extract it into an image so that we can download the image and then just load the image instead of creating that separate scene and doing all that at runtime. It should be a lot simpler. But we only need to generate the scene one time, make an image out of it, and then now that we have that image, we can get rid of all that code related to doing that. So we're making a blob out of this. The options you can pass in are the count and the size. Yeah, they're the way that we're using them here is not very typical. Usually these things are for, like in the modern day, I think, all you really use these for is if you wanted like a certain kind of look to your scene or your game or something. Or if you wanted to do like a level of detail kind of thing where you had some object way in the distance and there's no point in you know, putting a fancy mesh into the scene of that object when the object is so far away you're not going to be able to see all the details of it. So you would just create like a sprite or a billboard of it and then put a texture on it and say, yeah, that's the building or that's the car in the distance or whatever it is. And then the way that we're doing it here is that we're just getting different like angles of that object. So our camera here has been rotated around the object. Like it'll be hard to show you, but something like this, we're getting, you know, different views of the object here. And I think, you know, in this case we have 16 of them, so it's just creating 16 cameras and getting like a 360 view of the object. And that's what you're seeing here as the object rotates around, or the shell in this case. So let's be thoughtful about this. This will be the options. Count as a number, size as a number. And then here, let's just call this options for now, because I never remember how to do this exactly. It'll be a partial of the options, which means you don't have to pass anything in. And then this options will be optional. But, you know, if you don't pass anything in, we need some defaults. Let me check this text real quick. Okay. Oh, you guys can see the text. Whoops. See, that's the thing. I need to make sure that these things aren't shown on screen, but there you go. I don't think there's anything that needs to be hidden, but oh well. Yeah, so this is our options object. And, you know, normally we would do like options.count, but count is going to be optional, but we need this to be like well-defined. So I always forget how to do this. I want it to immediately like destructure this. And now these are still optional. So we would have to pass in default parameters here. Count will be 8. And now these are well defined. But I don't want you, if you like look at the signature of this, it's saying that you still have to pass in some object here. So you can't just call it like this. What do I call it? Sprite sheet blob. Like this, you have to, it still wants one argument. So you'd have to do this, which isn't very nice. So if that's not the case, then we'll just default this to an empty object. And now you can see there's no more error. It says that, you know, that options object is optional. Now we need to render. So we got our renderer created. Whenever you use the web GPU renderer, you need to wait for it to be initialized. So you call this a init thing. It will return a promise. That when that promise is resolved, then all the resources are ready to go on the GPU. So in your callback here, this is where we need to render. So we'll call renderer.render, and you always need a scene and a camera. But we don't have those, so we need to get those as parameters. And these will not be optional. You must pass in a scene and you must pass in a camera. And that's because, you know, you don't want us to render something. You want to, like, you have to tell us what we need to render. We're not just going to render anything. So you pass in your scene here. And then I'm going to leave this as array camera, because this sprite sheet, like the name of this object, or the name of this function, kind of tells you that it's going to be creating different sprites. It kind of tells you that the intended way that you use this function is with an array camera. You don't have to use an array camera, because the way that we're using this thing just only cares if the camera is, like if the second argument is a camera, which array camera extends from camera. Yeah, right here. Oh wait, it extends from perspective camera, which extends from camera. But array camera is a list of cameras. So we're gonna assume that when you call this function here, you've already set up your scene and your camera. We're not gonna do any of that for you. You need to do that before you call this function. So that's kind of like a prerequisite, or there's another word for it. Like, it assumes all that's been done. So we render to it. You know, we render to this canvas here. Once that's done, then after that we can create a blob out of the canvas. So we render to the canvas. Now we can call canvas.convert to blob. I think this also is a promise, yeah. So there's options in here, but I think it'll default to exactly what we want it to default to. Like, I think you can control if you want this to be a JPEG, but I think it defaults to PNG. And if it is a JPEG, you can like set its quality and stuff like that. So we don't need to mess with anything in there. But this will return a promise of the blob. And it's just a blob, so it's kind of just like raw data. And we can return this, and we'll return this. And you can tell, like, as it is, we got a promise of void, but that's because we're not returning anything here. But this is the correct signature. Yeah, there's three that I know of, and there's also stereo camera, like if you want to make a stereographic image, but I haven't really come across that. Like, I haven't really had a use for that. But this array camera is just a list of perspective cameras. But the way that you use it is you have to define the viewport of each camera. So camera has this hidden property of viewport, and that will be like, where in the scene do I need to render, or where in the canvas do I need to render this, whatever this camera sees. Where's the example? So this is using an array camera here. And I don't know why, but all the cameras are seeing the same image. But in our case, it's just going to be a row of these. We don't have any Y offset. We can get rid of this. But we don't just want to return the blob. We also need, now that we've rendered to the canvas, we can dispose of the renderer. And that should be the whole function. Like, you could pass in more things in here. That could be options here, but I want this to be kind of simple. And it's telling me here that I can convert this to an async function, which is true. And then that makes it a little bit simpler, like a little bit less indented here. And this still returns the promise of a blob. But now that you have the blob, wherever the user like calls this function, then they can do whatever they want with the blob. So that's why it's called sprite sheet blob. It's a blob that's intended to be used as a sprite sheet. So that's it for that one. But now we need to use it down here. So where we have the scene ready to go here, we've set up, like we put the GLTF in the scene here. We set its environment. This is coming from this promise up top here. The scene is like ready to go. It's ready to be rendered. And in this example right now, we're rendering to a render target that uses the target's texture right here in the sprite material. But now what we can do is sprite sheet blob, pass in the scene and the camera, and then here the count is defined at the top right here. So we've got 16 views of that object, and then the size, I think we called it RT size, but it might be better to rename that now. So that should be close to here. So this returns a promise. It will give you back the blob. And then now what can we do with that? We can create a URL out of it. This is just a static method, so url.create object URL, and we pass it in the blob. And now that has, like, that image has been put somewhere, you know, in memory or whatever, and now we can load it. So I have this helper function from some other part of the project for loading URL, like image URLs. So you pass that in, it will return a promise that is fulfilled with the image, And all I want to do, you wouldn't normally do this in Svelte, but I'm just going to put it in the document. Let's see. I got something wrong here. This is like a problem with closing parentheses and let me see. So that closes that one, this closes that one. Oh. There we go. But now down here, well, let's take a look at this, see if we get the image out. Oh, got some errors. Size is 0. Okay, let's see what size it is. Oh, that's not right. I know why. Because size is defined in this callback. Right here. So we should probably call this like sprite size. And then here we'll rename this thing to sprite size. Now if we look at the bottom, or let's see, where's our, oh, we need this to be size. Okay, we got our image. See if we can load this. There's nothing in it. So we have our image, but there's nothing being loaded into it. Or there's nothing being like drawn on the image. So if I take this out, where's the image? It says it's there, but we don't have anything showing. Oh, it's too big too. Isn't it? Yeah, it's like way too big. Oh, I know why, because I want to set this to be a smaller number. Where am I logging? Oh, the size is being logged here. And let's do this. I think this is right. Or maybe we don't need to dispose of this yet. Alright, time to look at the notes, see what went wrong. I don't think I have this part of it in my notes. Oh, yeah, we're waiting for that. We're rendering the scene. Converting it to a blob. We can just return this. No, we don't need to, because we need to dispose of this. Let's do this. You have to do something to make the render actually give you the pixel data? No, I think what's happening is something asynchronous is happening where it is rendering the scene, but for some reason it's not. Like, I want to test if we just put a mesh in the scene, if it can render that. Because I have a feeling that it is something to do with this texture load, this environment map loading at the wrong time. But we should still see the object. It just won't be lit. It'll be like a totally black object. Because there's no environment map yet. But just for debugging, I'm gonna make a box geometry and see if we observe drawing buffer. Oh yeah, it might be because it's getting cleared. But I'm not sure. I'll try that if this doesn't work. I'll just leave it as a default. Okay, so let's log the scene. It should. This is where you start to go crazy because you're like, I know this should work. But we have, yeah, one child in the scene. Our cameras are set up correctly. We don't even see, like, the thing in the main scene anymore either. Let's go here. Where's our scene? Where is our mesh? Hmm. It has the correct dimensions, so it's not a problem with these. And it's creating the URL, but we're not seeing anything. Like if I do this, we should see a yellow image. So let's see if this works. Yeah. So that's yellow, and then this guy's yellow. But it's not drawing that mesh. Normal material. It should have a white, I think, like by default they have a white basic material, so I don't think this will do anything, but let's see. I have to add it to the scene. Yeah, it's being added there. Are we rendering the scene? Yeah, we are, because the scene background's getting set. I don't think we need an environment map. No, we don't. Don't need one for this. Okay, let's see. We can just do this. These need to be types, not imports like that. Now here we can just set the camera to a new perspective. Camera, translate it. Okay, there's the mesh. So it's something with the camera, it looks like. uh, it's not very pretty because, you know, the aspect ratio is off and all that, but there's the mesh. It might be... Well, let's go over there and take a look. Camera, where's camera? Camera's right here. Let's just do the main camera. Can we still see the mesh? Yeah, right here. So I don't know why this isn't working with an array camera. And it has the viewports all set here. Oh, I know why. This is not the size anymore. This is the sprite size. So doing that, like, yeah, it's taking this size here. So this actually needs to be sprite size. This size here is used for positioning these cameras along the z-axis. And then once we so here's our object, and then we take the camera, and it's normally at the origin with the object, but this distance here pulls it back, and then we rotate it around the object with this method here, with this call here. So this should be the problem, and yeah, let's put this back on. We don't need this. Don't need this. And you can barely see it there. Yeah, you can see it. These are the shells and the different views of that shell, but they're black. They're not colored properly. And I couldn't figure out why that was, but it has something to do with this environment map here. But with this, you can, it's an image in the web page, so you can just download it, right? Save image. Or you can't see that, my thing is in the way. You can just save it. Or you can open it in a new tab. You know, here it is. But it doesn't have the right coloring on it, or it has no coloring on it. So something to do with this isn't getting set in time or something. Like there's some race condition happening, I'm not sure. But what we can do instead is just, rather than using this environment map that gets created here, I'm just going to load in an HDR texture and use that as an environment map. So this whole thing will just get thrown away. This will get thrown away, that'll get thrown away. And then we'll load that environment map right here where we load the model. We need an HDR loader. So we haven't made this yet, but let's make it. New HDR loader. Let's put this at the top in the module script and get rid of this. Here it needs a URL, so we can import the URL here from oh, how did I do this? Let's go here. So you can, in Vite, which, you know, Astro and Svelte and all these, they use Vite under the hood, or like, you know, behind the scenes. So you can just import assets, like their path to the asset, you can just import it this way. But this is going to be our HDR URL, and it's located in HDRs. And then I'm not sure which one will look best. I got a couple of HDRs in here. Let's just use this one. And we'll load that. This will be our HDR. This will be our environment map. Promise, but we need to set property of that texture, because this is like a cube map, so you need to set its mapping. So you get the HDR out here. You'll do HDR.mapping equals equirectangular reflection mapping. So that, you know, messes with the UVs so that you sample from this texture in the correct way. And then we'll just return that HDR. This is load async. And down here, might have to reload it. So now we have color on here, and that's because we're using, you know, we're not using that PM REM texture thing, and I don't know why that didn't work, but we don't need all that PM REM stuff. It's like if you were doing like mip-mapped textures and stuff, but we don't need to do that. We need to bother with it. And I think I want HDR that is a little bit brighter. So that's easy to do. You can just swap this out with one of the other HDRs. Maybe this one. And if we bump up the sprite size a little bit, yeah, it looks good enough. But here's our texture at the bottom here, or, you know, our sprite atlas. So let's see. I guess this thing's pretty wide, and textures eat up a lot of memory. And you can tell, like, this texture, like, a lot of these could be squished together. There's a lot of empty space in between these sprites. But I don't want to bother with that. But I do kind of want a smaller texture. Something like this. So let's save it. Maybe I'll call it abalone. Sprite sheet. It's a PNG. So now we have it, which means we don't have to do this anymore. Instead, we'll load that texture at the top here. I have to move it into the right location. We'll go to source, assets, and then we'll move. I think it's in downloads. Abalone, move it here. And now we can load it up like we do with all these other assets. So import abalone texture, or what is that? Sprite sheet URL from assets here. Now we can make a texture out of it. Oh, actually we need to load this like a texture loader, so go up top here. Like that. Texture. Load async. And then that's at abalone sprite sheet. And here we set the texture here, which means we don't need this at all. We don't need this. Well, we'll leave it here for now. But it needs to be renamed to texture. And this is a promise, so we have to await this. This is kind of like, do I just want to await it here? Just so that I can demonstrate it? I mean, I normally wouldn't await it. But if you await it here, you know it'll stop here and it will return the promise stuff. So maybe I'll just await it, just for demonstration. So now we get out the texture here. Oh, this is metadata, so it needs a string. So Vite recognizes that this ends in a .png, and then that means that this object here has properties on it. Oops. But the one that we want is the source. So there it is, but it's not getting its UVs set correctly, so we need to go in and modify all these. We don't do that anymore. Don't do that. We don't even need to render this anymore. We can get rid of all of this. Let's see. Yeah, there you go. So that cleaned it up quite a lot. And we can get rid of all of these imports. Don't even have to load the model anymore. Don't have to do this, don't have to do this. Don't have to do this. Look at all this that's going away. Don't have to do that. You got to do that. So it doesn't know what the count is. You kind of have to tell it, you know, how many sprites are in this texture. There's no way to tell. All you know is the width of the texture. Yeah, that got rid of a lot, but you know, you can kind of tell, like, that would be something that you would do at build time. You would generate that texture at build time. It would tell you where to find it. It would tell you the count. And then, you know, you'd have some, I don't know. Or you could run like a script or something that's like, before I build the project, generate all my sprite textures or something like that. And then, I don't know where you would go from there, but you know, what we did was we moved it from the runtime, like doing all that scene generation and texture generation, into a static like file or something, right? So here's the file here. Is it in assets? I wanted to show this too, but I forgot. What do they call it? Abalone. Yeah, so here it is. It doesn't have the right colors because we need to set the color space of the texture. So you would take your texture. Where's the scene? You take your texture. I think it's actually a part of the renderer. So down here, you would match the renderer's color space. And I think it's under current color space. I don't know. Color space, is that it? Yeah. Yeah, so now it has the like same color space as the renderer. That's now the colors that you see here match up with this color. Yeah, so that's that. And then that's part one of what I talked about in the beginning. Look at all this stuff that just goes away. That's cool. But I want to clean this up too. I don't really like this. Like, it's kind of hard to tell what's happening here. So I want to use TSL to do this, and this here. Let me turn this down. This is all about calculating the offset for the texture to tell you, like, to tell it where to get the next sprite or the current sprite. And I kind of talked about this in the last stream, like where the math comes from and how to derive it and stuff. And we can easily kind of swap this out with a node material. Still has the map property, so it's still working. But if you want to replace, so map and color, like if I put in black here, these two values get multiplied in the shader, and you can tell it's totally black. If I put white here, it'll be, you know, white is 1, so the map here multiplied by 1 just returns the map. Or you can do something in between, like if you wanted to dim the image, you know, you'd put in some gray color, like this, but you have to turn it into a color. Pink. Maybe you can leave it like this. That's white. Let's do this. But anyway, these two values get multiplied. So this whole thing is replaced with a color node. These two, and your normal sprite material, if you're dealing with TSL and node materials, they get merged into one property, this colored node. And what we can do is take a texture of, this is called texture, so let's call it something else. Let's call it like sprite sheet texture. So we'll take the color node, texture comes from TSL, and what is this? Sprite sheet texture. And if we take these out, and it's still working. But now I don't want to use this like repeat and offset stuff. So this texture, where is it? Texture has a second argument here, which is the UVs, and they default to the UVs of the like buffer geometry and stuff. So if you pass UV in here, you'll get the same result. Well, not the same result, because now we're not modifying the UVs any. This is the actual like texture in memory, and we're sampling the entire texture. But now we need to modify the UVs so that we only grab hold of like one of the sprites, and that's what's happening here and here. So the UVs, they go from 0 to 1. We know that each of the sprites has a width of, so from 0 to 1, how many of these do we have? Well, it's the count. You know, if you have like 8 sprites, each of those will have a width of the total width of the texture divided by the count. Because you have 8 sprites in there, you add up all 8, you get your total width of the texture. So each individual sprite, and what I mean by sprite is each of these little cells of the image has a width of 1 over the count in UVs. That's in like the UV space because we go from 0 to 1. If you wanted to take the texture space, I don't know if that's the right name for it, but you wanted to map it from like, 0 to 8 or the count space or whatever, right? You would just divide this by 8 on both sides. But our UVs originally go from 0 to 1. So in the UV space, each of these has a width of 1 over the count. Normally it would be 8 over the count, but or the width over the count. But our UVs start at 1, so we just do 1 over the count. And that's what's happening with the offs or the repeat right here. So that is the width. Now where do we start? That's what this offset is. So the start, I'll just call it S, I guess, for start. We know that it's going to be some multiple of the width. So this is like 0. This start here, this is 0 times the width. That'll give us 0. The width here is W, so each of these has a width of W. If we want to start here, that's 1 times the width, and so on. It's 2 times the width, and all that. So it's some index times the width here is 1 over the count, or we can just do I over count. You multiply I by W. And I'll just call it C. So C is for count. So that's our starting position in the X coordinate, the X like range or whatever. Now where do you end? That would be, we know that each of these has a width of 1 over the count, so the end is wherever we started plus W. And that can be reduced to I over C, that's just a substitution, plus 1 over C, and then these have the same numerator, so it's 1 plus I all over C, and we need to go, that'll be our stopping point. So we started here into that texture, and then we ended here. So we want our range to go from, they go from 0 to 1. We need to map that range to the start to the end. And the start is I over C. And we need to go to 1 plus I over C. So we need to manipulate the UVs to be in this range here. So the easiest thing to do is to find what you need to multiply this by, and then, so there's 2 steps to this. You scale it up, or you scale it to whatever, like, you need it to be, and then you shift it over. So shifting it is just an add or subtract. So we know that this value here needs to be I over C. So we need to shift, the second step, we need to shift by I over C. And that's an addition. So what we need to multiply by is this number here plus I over C, because what we're going to, or it's actually subtract I over C, because this will get, if we take this number here, and we can actually reduce it, this will be 1 over C because the i's will cancel. This is what we're going to multiply the 0 to 1 range by 1 over C. So we do that on both sides. 0 times that will be 0, and this will be 1 over C, and then we need to add I over C on both sides. Now we have that I over C to 1 plus I over C, because these can be combined. And that's what we wanted originally. The start is, where's the S? Start is I over C. The end is 1 plus I over C. And that's what we have right here. So how do you do that in three.js? In the TSL, with these like node functions. Where is it? Here. So you take your UV, and this is 0 to 1 in both x and y. We need to multiply it, and we only need to change the x because we didn't offset the texture that we have here. There's only one row of sprites. We don't need to modify y at all. So when we multiply, we want to multiply by the identity. So we know that the y in this case is 1, but what is the x? That's going to be 1 over c, or 1 over count, which we calculated here. Right, the I over c here, or the 1 over c rather, 1 over the count. And then we need to add, only in the x, we need to add the I over c. So we can't do divide here. We can. Like this will work. There's no errors here. We can save it, clean it up. And then we can add to this. Make sure this is right. Yeah, we needed to do the addition identity on the y, and then this is going to be I over the count. But we don't have I, and that's going to be a uniform that we can modify. And we'll just set it to 0 for now. Oh, we need to do .div. So you can't just do like I divided by something, because this isn't a number, this is a uniform node. So we have that. Now if we take a look at the texture here, so I is 0, so we're getting that first sprite. If I bump this up to 1, or let's go like even deeper into it, 5, you can see I'm getting different textures. The Y is wrong, I think. Yeah, it's like cutting it off. That's weird. Oh, I know why. This needs to be a vec2. Because if you just pass in a number into these, it will just take the first argument and apply it to both components of the vector. Right, so that is the backside. 0, which it is initially, is the front side. Yeah, it was applying it to the Y as well. Which I don't think that should be the case. I wish they would overload these things to allow you to do like, you know, some X and some Y. Because it doesn't really tell you that's what's happening. It just, this thing is only overloaded for like one argument. And it doesn't even tell you that you can't pass in a second argument. Or maybe it does, let's see. Oh, it just says that these aren't defined. What's the problem? Yeah, like, what's the second argument? Okay, parameters. I don't know. But this is kind of the problem with TSL at the moment, is that the docs are kind of hard to, there's not much documentation. The only like real thing you have to go off of is this. Not this. This whole big thing. Yeah, this thing here, I guess. I don't know, whatever, like all of these are kind of on the same page. You have that, and then you have the wiki. So that's at three.js. Shading language. It's in the GitHub, this thing here. Which is a pretty big document, but there's so much in here. And I don't know, I think it could be improved. But I can understand why they haven't really touched, or they've done a lot with it. I'm not saying, like, I'm not trying to downplay it or anything, but I think it could be improved. But I can understand, like, this is still uh, being worked on for sure. And I don't even think it's like production ready or anything like that. Yeah. There's a lot going on here. Um, and it took me a while to understand a lot of it, but I've been working with it now that I kind of get what things are doing, and you kind of like if you have some error that you're not sure, like why did it happen this way, or why is it doing this or whatever, I kind of know where to look. But that's the way it is with like all software and all code bases and stuff. You kind of just learn its quirks and stuff like that. Typing's instead of waiting for yeah, that's the other problem, is that like when you have a shader error, you can't, it's so hard to debug shaders. The only way that you can debug a shader, well, I don't think this is the only way, but you have to like figure out a way to debug it in terms of like what you see in the shader. So you would do things like, are my UVs correct? Well, let me take a look at the UVs. Are my normals correct? Let me take a look at the normals. Stuff like that. You have to find these like little tricks on how do you know if, um, what you see is what you expect, stuff like that. I think these can be combined. Let me make sure that's true. Well, maybe not. Yeah, I don't think so, because there's no way to take something like this, a times x. This is kind of essentially what we have in these two steps, and there's no way to combine these terms because they don't share any common terms, right? But now, instead of adjusting this, you can see like it's not rotating on its own anymore. I thought that was one of those like free streamers, or like, free viewers here. It's actually the bot, so that's good. I forgot I set that up. All we need to do now is just modify the uniform. So here, yeah. I haven't gotten one yet. I usually get one per stream of those people that, those bots that are like, go here for free viewers. I haven't gotten one, so this will be a first. The very first stream without one of those bots they have to ban. So here, I know that we're going from this here. If we log out the angle, let's see what we get out. Oh, what the heck? Oh. So we're getting 0, we're getting 1, we're getting values up to 15. So that's our I, pretty much, right? We would take that, or that's our uniform. So what did I call it? I called it I.value. Equals the angle. Let's see what that does. But it's not the angle, it's actually angle divided by the count. I know it is the angle because of how we use it here. We're always dividing by the count here. But it's not in the right direction. So you can see, like, we should be seeing the left side of the shell, but as we rotate, we start to see the right side of it. So we need to flip this and take the count minus this number. So count here is 16, right? So 16 minus something like, this goes up to 15. Remember when we logged it out here? So we actually need to take this minus 1. And there you go. Like, if we don't do that minus 1, you take a look at the angle here. there's two things you'll notice is that we don't see the texture here. And that's because right here it's got a value of 16, so it's offsetting the UVs all the way to the end of the texture. Because we have 16 over 16 right here. So that offset, like this will become 1. Everywhere where you don't see it, right here where the count is 1, it's 16 over 16. So we're offsetting all the way to the end of the texture and there's nothing there. So that's why we have to subtract 1 right here. Now we are in between the ranges of 15 to 0, I guess. Or I guess it would be 15 to 0, right? Whee! There you go. So that got rid of that weird... Like, I always thought that this API, it's repeat. We don't even need to do this anymore, right? Yeah. I always thought that that texture.repeat and texture.offset were a little confusing if you don't know about UVs. These two things. But I think it does tell you that this is in the range of 0 to 1. Yeah, in each direction U and V. And the offset, yeah, typical range is 0 to 1. So it's telling you that much at least. Now if you're, this is kind of off topic, but if your offset is more than the width of the texture, you can set what happens when you try to sample a texture that, try to sample a texture outside of the texture's UV coordinates, and that's your wrap S and wrap T here. So that's the like mirrored wrapping and the clamp to edge and stuff like that. So I think, there would be a little optimization here too if like, well, it doesn't really affect anything if we don't put this behind an if block. Because we're always going to need to calculate this. Here, we'll get out a float. Or a decimal number. So we can't put it there because of like floating point arithmetic and stuff. We'd have to put it here if we put this behind an if block. But doing this every frame or every change event here is not a big deal. So we don't really need to, like if you look at the code that's on the GitHub at the moment, there's like a last angle property. You don't need to worry about that. Or not property, but a variable. What time is it? 2:46. I don't want to go work. I don't want to go to work. I'm just gonna be like, look, I was actually busy doing something, They tried to call me into work, but I'm busy. Yeah. They'd be like, what were you doing? No, they don't really care. I worked already for like 40 hours this week, so I'm at my full time. I mean, I could get some overtime, but it's just not worth it. I'm not a very busy person, but you caught me when I was actually doing something. I'm talking about work, you know? Um, what do I want to do now? This is kind of all that I wanted to achieve today. Um, I don't necessarily like. I kind of want to come up with an idea or a plan for how, because there's a lot of asynchronous stuff here, like this, and this will wait here until this texture is ready, right? You can't do any of this until we wait for that texture, but a lot of this doesn't depend on the texture. Um, and kind of want to come up with a plan for how to like do a convention or something for how to deal with asynchronous resources and stuff. Um, but I would probably do that off stream. But I guess I'll kind of describe what the whole point of doing this was. So before these streams, this kind of what do you call it? Saga. That's a good word. This sprite sheet, rotating sprites saga. The example that I had was using this Boo sprite sheet here. And I had to take this like image and I had to process it to get these to all be the same width, each of these sprites to be the same width. But the width was not a nice like power of 2. I think it was like 38 pixels or something like that. And what you see here was doing, you know, it would pick the correct sprite depending on the rotation of the camera and all this. But every now and then you would get a little bit of like artifacts of like little pieces of like the next sprite because indexing or like sampling from that texture, you know, you have to deal with floating point numbers and stuff. So there's a little bit of inaccuracy involved. And that's because our dimensions of the sprites weren't nice like powers of 2. And you could probably, like, if you wanted to use this sprite, you would just need to find, like, what's the largest power of 2 that would, you know, I'd put each of these into its own little cell in the texture. And as long as the width of that cell is a power of 2 and it can contain the whole image, then I'm good. But I wanted to do something that didn't involve, you know, this is somebody else's asset. And I guess you could say this is somebody else's asset too, this GLTF, but it's part of this Chronos model, sample models and stuff. And all these have pretty like permissive licenses and stuff. The one that we're using is right here. This is alphabetized, I think. Yeah, right here. So this is the license that it has, and it's is this Community Commons or Creative Commons license, which are like pretty permissive licenses. So that was another reason to use your own model, right? Or to not use like Nintendo's model. I don't know. Nintendo won't come after me, I'm sure, but especially if this is for like educational purposes, right? I'm not making any money off of this. They're not losing money on this like little demo I made. Yeah. That's funny. I'm calling Nintendo right now. But yeah, so and I kind of wanted to experiment with a way to create you know, what's talked about in this three.js article. I think I might still have it. Billboards right here. And let me link that in the chat in case anyone's here or anyone wants to look at the article. But at runtime, they're doing that thing that I showed at the beginning of the stream where they're creating that scene. This is their little scene here. And they're rendering it to a render target and using that target's texture as a map for sprite material. Um, so that was kind of interesting. Like now we're just loading the texture with the texture loader, but we created that texture, and we have the function to do it right here. Oh, I need to dispose. Yeah. And it's pretty good results, I guess. This texture is like pretty big. There's a lot of empty space in the texture. And using it in this way, I don't think is very common, but you know, like you can imagine if you had a game or something and this was the style of the game, like all those 2.5, what do they call it? 2.5D games. They use, most of the time, I guess, they use sprites. Um, there's Paper Mario in here? But if you take a look, I'm just going to use this as a resource. Like, they're faking 3D with sprites. So if you ever played Mario Kart, the drivers aren't actually 3D models. They're just sprites that are, like, you know, they're just a big sprite atlas, a big texture, and then you're sampling from that texture to make it look like the model is actually 3D. So maybe your game or your scene or something is, you know, doing the same, and it's a stylistic choice, I guess. But if you look at like other Nintendo games in this era, like Paper Mario, it's kind of the same idea. If you look at Mario sprite, you know, there's no, it's a sprite. There's no 3D model involved, and that's because they're using a sprite, right? Um, so I don't think they're loading this whole thing at runtime, or like they're probably loading it per scene. You know, when you go into a new room or something, then they're loading, you know, this maybe this subtexture of this thing, or you know, we don't know how this is laid out in memory. Somebody just ripped all these images and put them on a big canvas, pretty much. So they're probably not loading the entire like sprite sheet, all of Mario's sprites in the beginning. They're probably either loading just a subset of that texture and or they're loading, you know, they're probably loading a subset of it, and then they're loading you're either swapping out that um sub-region or whatever, you know, as you go into different scenes, as you go into a new room or through a transition, you know. I don't know if anybody's played Paper Mario, but on every like edge of the map or something, there's a little thing that you go through, and it's like a door or whatever, and then the scene changes, or the like, you know, the environment changes and stuff. Uh, so yeah, I'm just thinking of like when would you really want to do something like this? Um, so that's one thing I can think of, and then obviously like they talk about in the article here, at the bottom, this whole section here says, well, if you're doing like a level of detail kind of thing, or you know, kind of what it says here, 8 directions around the object show based on the direction of the camera. That's exactly what we did here. So they don't show you how to do that here, but because their model is symmetric, so if you take different shots around this tree, which is really just a cone with a cylinder attached to it, you're going to see the same thing no matter where you rotate the camera, right? So that's it. Do I have anything else to say? I don't know. I don't think so. Anybody have any questions? Oh, let's see. Yeah, I was supposed to... Oh. Yeah, it doesn't like spam. I gotta go in there and change some settings of Nightbot. Can I do this? Oh, dang it. I don't know how to type into the... Oh, there it goes. I don't even know if I have like, what do you call it? The extensions in OBS. But here you go. There you go. Yeah. Uh, yeah, I have to go in and edit Nightbot again and say, don't be so strict. You know, allow the same message over and over again. That's fine. So. It always has this weird, oh, stop spamming emotes. Yeah, that's, I mean, what do you do when, like, the chat is hype and all that? You know, everybody's excited and everybody's spamming emotes, you know? I could probably do that right now. Oh, I have to log in. Because I'm in a private window over here. Allow some spamming. Yes, spamming in moderation. Everything in moderation. You know? So I'll upload this to, or I'll push this to GitHub. I might clean it up a little like I always do. And then once the stream is ended, I'll upload the VOD as well to YouTube. So if anybody wants to rewatch it, it'll be there. I need to find out a way to how to do that automatically. But there's probably some Twitch API I can use. But I don't know, I've been working with 3D so much, I don't even know how to do like normal programming anymore. And that just sounds so boring to me. Just what I said just now just sounds so boring. Oh, thanks for coming in and sticking around. Hopefully I explained things pretty good. Are you gonna stream today? Probably, maybe, I can't remember. But if you are, I will probably, unless it's like really late, I'll probably tune in. Because I have to go to work at 4 in the morning tomorrow. Leaves and branches, yeah. Okay, I'm gonna end it here. Thanks everybody for coming by and watching and chatting. Hope everybody has a good weekend. I'm gonna go get some lunch. Probably be a chicken sandwich. So, I'll see you guys later, and bye.